I'm Gary. Today we're going to demonstrate the advantages of using Blaco's patented inlet stabilizer in a situation of suction lift conditions to the inlet of the pump. To do this, we're using an air-operated double diaphragm pump, the Blaco patented inlet stabilizer. The discharge of the pump is being dampened and smoothed by one of our discharge pulsation dampeners, and we are pulling liquid about 6 feet up from a tank down below on the loading dock. Air-operated double diaphragm pumps especially are prone to unbalanced loads on the suction stroke of the pump, and if it is pulling too high a vacuum, it strains the diaphragm because it has two diaphragms and they're connected with a common shaft. On the discharge stroke of the pump, when liquid is flowing out, the shaft is mechanically pulling the diaphragm in to create a low pressure area to fill the other side. The harder it works against a suction lift, the more unbalanced load there is on the diaphragm. By using Blaco's inlet stabilizer, we can minimize the unbalanced load on that diaphragm and often extend the diaphragm life many times over what it would be without the inlet stabilizer. It's important that the inlet stabilizer be mounted as close to the inlet of the pump as possible, because it actually accumulates liquid in it during the pump shift and provides a steady flow of liquid and pressure to the pump during the shift. The area downstream of the dampener is still pulsing and showing a high suction lift, and will have acceleration head losses occurring from the dampener, the inlet stabilizer, to the pump. There will be no suction loss or acceleration head loss that has to be made up. In effect, the inlet stabilizer makes up the loss of the acceleration head. Now, as we turn the pump on, I have pressurized the inlet stabilizer with 20 pounds of pressure. This pushes the bladder down and seals off the dampener, so in effect it has been taken out of the system. As you can see, with the inlet stabilizer not functioning, we have a lot of vibration going on that occurs every time the pump shifts and a valve ball closes. This is damaging to pipe components, gauges, flanges, and other areas on the inlet side of the pump. Now, since we're pulling a suction lift, I need to put a vacuum in the inlet stabilizer. And I do that by opening the airtight ball valve and running a high pressure air through the venturi valve. Now remember that air flowing quickly is at a lower pressure, and you can see that I am starting to create an accumulated amount of liquid in the inlet stabilizer, and that the bladder is pulsing with every pump stroke. At the pump, between the inlet stabilizer and the pump inlet, we are showing a small positive pressure. In effect, we have created a flooded suction out of a suction lift condition by installing and operating the inlet stabilizer. Now, I'm going to again take the inlet stabilizer out of the system by pressurizing it, and you'll see that now the pump will be seeing suction lift. Now our pipe is vibrating again, and we are pulling about 7 to 10 inches negative pressure into the pump. This high negative pressure puts strain on the diaphragm on every suction stroke and will significantly reduce its life expectancy.